Hello, good afternoon, students. So today, instead of sir, I am taking today's class. Okay, we just swapped our classes. He will be engaging on Thursday. So today's topic is that is dual nature of radiation and matter. Okay, so dual nature of radiation and matter. It is one of the easiest topic anta na helbodu. So ee concept alli namge hardly 2-3 ಫಾರ್ಮುಲಾಸ್ ಬರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ನಮಗೆ ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ ಅದನ್ನ ಬಿಟ್ಟು ಬಾಕಿ ಎಲ್ಲ ಥಿಯರಿ ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ ಇಲ್ಲಿ ಆಯ್ತಾ ಸೊ ವೆರಿ ಸಿಂಪ್ಲೆಸ್ಟ್ ಟಾಪಿಕ್ ಇಟ್ ಇಸ್ ಡ್ಯುಯಲ್ ನೇಚರ್ ಆಫ್ ಮ್ಯಾಟರ್ ರೇಡಿಯೇಷನ್ ಅಂಡ್ ದ ಮ್ಯಾಟರ್ ಹಿಯರ್ ಮೇನ್ಲಿ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದಿ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ yes the Davison Germer experiment we will discuss then the Einstein's photoelectric effect and the conclusion of the experiment that all points we will discuss in this lesson. Okay, so based on the Einstein's experiment, we have some of the what we can say, the assumptions are there. Adanella navu illi discuss madbodagide. Yes, so let us discuss some of the points, then we will go for the question answers. So dual nature of radiation and matter. So here, what do you mean by this dual nature? Dual nature anta andre, here the light is exhibiting two natures. That is, one is particle nature and the other one is wave nature. So ಅದಕ್ಕಾಗಿ ನಾವು ಇದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ dual nature ಅಂತ ಹೇಳ್ತೀವಿ. Okay, the light is exhibiting both the natures, that is the wave nature and the particle nature. So here, which all the experiments are there which will tell you about the wave nature and about the particle nature, that we will discuss one by one. So before going to discuss that, here first point in this lesson is that is photoelectric effect. So what is photoelectric effect? The photoelectric effect is nothing but here on the metal surface. Suppose if you consider the metal surface, we know that the metal surface are consisting of free electrons. When the suitable light of certain frequency and the wavelength falls on this metal surface, the free electrons get emitted. The free electrons get emitted, or it will get ejacuated, or it will get eliminated, it will get escape out. Yav tara bekadru terms you will use madbodu. So the electrons, the free electrons will escape out from this metal surface. This phenomena is called as what? Photoelectric effect. Photo ಅಂತಂದ್ರೆ ಏನು? Photo ಅಂತಂದ್ರೆ light ಅಂತ ಆಗುತ್ತೆ. Electric. So here when the light falls on the metal surface, the electrons will get ejacuated, or it will get escape out from the metal surface. This phenomena is called as photoelectric effect anta ಹೇಳ್ತಾರೆ. Okay, so here we will see four types of electron emission. So we have the electron emissions four types alli ಆಗುತ್ತೆ. So what are the four types of photoelectric emission or the emission of the electrons? Can you people tell me one by one? There are four types of emission of the electrons. Yes. What are the four types of electron emission? Thermionic emission. Yes, Damini, very good. Thermionic emission. Other three. Yes, students, Abhishek, Akash, Damini, who all are there? Jyoti, Kumar, Madhumati, Monica. Yes, Parvati. Field emission. Yes, correct. Photo emission. One more. Rakshita is giving photo emission. Akash is saying for field emission. Yes, Virat is telling thermionic emission, photoelectric emission, secondary emission, and a field emission. Yes, very good, Virat. Yes, correct. So here there are four types of emissions: thermionic emission, photoelectric emission, secondary emission, and the field emission. So thermionic emission, as the word indicates or the term indicates, thermionic antandre heat anta agatte. So due to the heat, the electrons are getting eliminated, or it will escape out. That is thermionic emission. Photoelectric antandre when the light falls on the metal surface, it will get eliminated. Secondary emission and the field emission. This is with respect to the field, electric field. We will discuss that. Okay. So we have total four types of electron emission process. So based on that, we will get some of the questions in the theory part of this lesson. Okay. Then next, here The photoelectric effect, the first time it was discovered by, that is Hertz in the year 1887. In the year 1887, Hertz will discover this phenomena. When the light radiations falls, the electrons will get escape out from the metal surface. This is called as what? Photoelectric effect. First it was given by Hertz here. So slow later wherever the concept will come, electron emission antandre naಮಗೆ ಗೊತ್ತಿದೆ. What is electron emission? That is the free electrons are eliminated from the metal surface. That is called as what? Electron emission anta ಹೇಳ್ತಾರೆ. So for the electron emission we require some minimum energy. Can anyone tell me what is that minimum energy is called as? The minimum energy is required to eliminate the electron from the metal surface. That minimum energy is called as, yes, threshold frequency. I'm asking energy, not threshold energy. The minimum energy required to take out the electron from the metal surface. That is called as work function. Yes, Shilpa, correct. So it is work function. So what is work function here? Work function is nothing but what? The minimum energy required by an electron to escape from the metal surface is called as what? Work function of the metal. It is called as work function of the metal. The work function is usually expressed in terms of electron volt. Okay, so it is also expressed in terms of joules here. Here 1 electron volt is equal to, we should know the conversion ಎಷ್ಟು ಬರುತ್ತೆ, 1.6 into 10 raised to minus 19 joules ಅಂತ ಬರುತ್ತೆ. Okay, so you told me about the thermionic emission. So what is thermionic emission? So thermionic emission ಅಂತಂದ್ರೆ, here we are heating the metal surface so that the sufficient thermal energy is entering to the free electrons and the electrons are able to come out from the metal surface. This is thermionic emission. Then we have the field emission. What is field emission? Here by applying very strong electric field, the electrons will come out of the metal surface, is called as field emission. Then last one is photoelectric emission. This is what? When the light falls on that, the light of certain frequency, when it falls on the metal surface, the electrons will get eliminated from the metal surface, is called as photoelectric emission. So here I told you about work function. Work function antandre enu? The minimum energy required for the photoelectric effect is called as work function. So now the minimum frequency required for this process is called as, it is already some people have replied in the group, that is threshold frequency anta ಹೇಳ್ತಾರೆ. It is called as threshold frequency. The minimum frequency required for this phenomena is called as threshold frequency. Okay, then next, so whatever the photoelectric effect experiment is there, that experiment here I'll not discuss that experiment, just at the conclusion anna discuss madana navilli. So here the first point about the photoelectric experiment, that result is what? That is the effect of intensity on the light. Here what happens, the electrons enagta ide, it is getting come out from the metal surface. So electrons motion alli iddaga ಏನು ಸಿಗುತ್ತೆ ನಮಗೆ? electric current ಸಿಗುತ್ತೆ, ಹೌದಾ? So ನಮಗೆ electric current ಸಿಗುತ್ತೆ. So when this electric current is there due to the photoelectrons, this electric current is directly proportional to the intensity of the light ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂತಂದ್ರೆ ನೀವು ಎಷ್ಟು ಇಂಟೆನ್ಸಿಟಿ ಲೈಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅದ್ರ ಮೇಲೆ ಇದು ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ. Okay, then next, the effect of potential. The effect of potential is represented like this. Photoelectric current ಮತ್ತೆ intensity, it is graph is, it is a straight line ಬರುತ್ತೆ ನಮಗೆ, ಆಯ್ತಾ? ಇಲ್ಲಿ intensity of light ಇರುತ್ತೆ ಮತ್ತೆ ಇಲ್ಲಿ photoelectric current ಬರುತ್ತೆ. Then for the potential, the nature of the graph is, it is somewhat like this. That is for different light, the graph is, this is photoelectric current, that is photo current along the y-axis. Okay, then the applied potential is along the x-axis. The nature of the graph is somewhat like this. Hauda? Here you can see this one. ಇಲ್ಲಿ graph ಏನಾಗ್ತಾ ಇದೆ, straight line ಆಗ್ತಾ ಇದೆ. Straight line ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೇನು, the current is becoming saturated. Saturation current ನಾವಿಲ್ಲಿ achieve ಮಾಡ್ತಾ ಇದೀವಿ. Okay. Then we have the frequency relation also. So the frequency relation, it is opposite to whatever the graph you have seen for the electric current and the potential. So it will come like this. That is the saturation current. So this is how the frequency graph is there. That is the frequency versus the electric current. Okay. So for different metals, the nature of the graph will be different here. So the frequency and stopping potential also we can see. The frequency versus stopping potential. So this is stopping potential and this is the frequency. So the nature of the graph is straight line. So this is for different metals. Okay. So now we will discuss what is stopping potential and Einstein's relation for that. So Einstein's photoelectric equation is given by, that is h nu is equal to 1/2 m v max square plus w naught. ಆಯ್ತಾ, ಇಲ್ಲಿ h nu is the energy, nu ಅಂತಂದ್ರೆ frequency ಆಗುತ್ತೆ, h ಅಂದ್ರೆ Planck's constant ಆಗುತ್ತೆ, half m v square is nothing but the kinetic energy, w naught is nothing but it is the work function. Okay, it is the work function. So we can also substitute the value of work function as, now ಇಲ್ಲಿ work function ಅನ್ನ ಯಾವ ತರ substitute ಮಾಡಬೇಕಾಗಿದೆ, it is given by hc divided by lambda naught. It is hc divided by lambda naught. Okay. So this is the general expression. Now ಆಮೇಲೆ ಏನ್ ಮಾಡೋಣ, ನಮಗೆ ಯಾವ್ದು ಟರ್ಮ್ ಬೇಕಾಗುತ್ತಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ನಾವು equation change ಮಾಡ್ತಾ ಹೋಗೋಣ. You just remember the main equation here. Okay. Then the de Broglie hypothesis. Then we have the next one, that is de Broglie hypothesis. So what is de Broglie hypothesis? According to de Broglie hypothesis, the wavelength of the matter particle is given by, it is lambda is equal to h upon p. H is Planck's constant, p is momentum, lambda is the wavelength here. It can be also written as h divided by m into v. Yes. So this is the relation between the wavelength and the momentum. We can write the relation between the wavelength and the kinetic energy also. It is h divided by under root of 2m into k. This is the relation between wavelength and the energy. Then next we have one more equation. Lambda is equal to 12.27 divided by under root of v. This is in terms of angstrom. It is in terms of angstrom. Okay. So here when we substitute the value, we can get, this is the one more equation, de Broglie wavelength for an electron. This is the de Broglie wavelength for the electron. So remember these formulas so that it will help us later to calculate the value. Okay. Now let us go for the question answers. So ಮತ್ತೆ ಅಲ್ಲೇನ್ questions ಬರುತ್ತೆ discuss ಮಾಡ್ತಾ ಹೋಗೋಣ. Identify the process in which an electron escaped from the metal surface. Yes. So it is option A. Yes, correct. Correct. Option A is correct. Then the next question. How many types of electron emissions exist? Yes. How many types of electron emissions exist? Yes, option C is right. Then the next question. Which of the following are quick electron emission? Photoelectric emission, field emission, secondary emission, thermionic emission. Yes, it is field emission. Correct. It is. That is field emission. Option B is right. Which of the following are quick electron emissions? That is the field emission. Okay. Then the next question. Thermionic emission is dependent on temperature. Yes. Thermionic emission is dependent on temperature. True. Yes. Correct. Yes, students, if you know the theory, the lesson is very easy. ನಾನು ನಿಮಗೆ beginning ಅಲ್ಲೇ ಹೇಳಿದ್ದೆ. ಹೌದಾ? The next question is, find the wrong statement. An electron gun is to create electrons and then accelerate them to a very high speed. Thermionic emissions and photoelectric emissions are the same. The kinetic energy of photoelectrons vary. Vacuum tubes are thermionic devices. Yes, which one is right? Yes. B or D? Which is a wrong statement. An electron gun is to create electrons and then accelerate them to a very high speed. Thermionic emissions and photoelectric emissions are the same. The kinetic energy of photoelectrons vary. Vacuum tubes are thermionic devices. Which one is right? Yes, B. So thermionic emission and photoelectric emissions are same anta ಹೇಳ್ತಿದ್ದಾರೆ, same ಆಗಲ್ಲ. Here no doubt ಎರಡು process ಅಲ್ಲಿ the electrons getting emitted, but thermionic emission ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, heat we are using. Photoelectric emission ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, we are using the light here. Okay. Which photon is more energetic? A red one or a violet one? So which is more energetic ಅಂತ ಕೇಳಿದಾಗ ನಾವಿಲ್ಲಿ ಎನರ್ಜಿ ಮತ್ತೆ ವೇವ್ ಲೆಂತ್ ರಿಲೇಷನ್ ಅನ್ನು ನೋಡೋಣ. ದಟ್ ಇಸ್ ನಮ್ಗೆ ಈಗ ಗೊತ್ತಿದೆ, ಅಕಾರ್ಡಿಂಗ್ ಟು the light wave is in the form of a small packet. That equation is given by, the energy equation is given by E is equal to h nu. Nu is the frequency here. Okay, so it is written as hc divided by lambda ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಹೌದಾ? ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಏನಂತ ಬಂತು ಈಗ ರಿಲೇಷನ್, E and your wavelength, ಎನರ್ಜಿ ಮತ್ತೆ ವೇವ್ ಲೆಂತ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ. ಸೊ ಎದ್ರದ್ದು ವೇವ್ ಲೆಂತ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅದ್ರದ್ದು ಎನರ್ಜಿ ಕಡಿಮೆ ಇರುತ್ತೆ. ವಾಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಹಿಯರ್, ಅವ್ರು ಏನ್ ಕೇಳ್ತಿದ್ದಾರೆ, ವಿಚ್ ಇಸ್ ಮೋರ್ ಎನರ್ಜೆಟಿಕ್. ಸೊ ಬೋತ್ ರೆಡ್ ಅಂಡ್ ವೈಲೆಟ್, ರೆಡ್ ವೈಲೆಟ್ neither. Yes, yes, correct. So that is option C. Parvati, Damini, all are saying the answers. Yes, correct here. So violet is the correct answer. ಯಾಕಂತ ಅಂದ್ರೆ ನೀವಿಲ್ಲಿ ಕಲರ್ ಅನ್ನ ನೋಡಿದ್ರಿ ಅಂತಂದ್ರೆ, that is the rainbow formation, ವೆಬ್ ಗಯಾರ್. ಹೌದಾ? So VIBGYOR. So ಇದು ಏನಾಗ್ತಾ ಇದೆ, this is in the form of increasing wavelength. Increasing wavelength ಅಂದ್ರೆ ಇದ್ರದ್ದು ಕಡಿಮೆ ಇದೆ, ಎಲ್ಲದಕ್ಕಿಂತ least wavelength is for violet, and for the maximum wavelength is, it is for the red. Yes, So therefore option C is correct. Then the next question, if the wavelength of electromagnetic radiation is doubled, what will happen to the energy of photons? What will happen to the energy of photons? Yes. So again, let us see the equation. So ಈಗಷ್ಟೇ ನಾವು ಬರ್ದಿದ್ವಿ, that is the wavelength and the energy relation E is equal to hc divided by lambda. Question ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, what will happen to the energy of a photon if the wavelength is doubled? ನಿಮ್ದು wavelength twice ಆದ್ರೆ energy ಏನಾಗುತ್ತೆ? Remains the same, doubled, it reduces to half and it becomes infinity. Samarth is giving two options. ನೀವು CET ಅಲ್ಲಿ ಎರಡು ಆಪ್ಷನ್ ಮಾರ್ಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. Yes. Double ಹೇಗಾಗತ್ತೆ? Here you are not getting twice. Wavelength double ಆದಾಗ see, ನೀವೀಗ ಒಂದು equation ತಗೊಳ್ಳಿ, that is E is equal to hc divided by lambda. This is your one equation. Okay, so I'll name it as E1. So my E2 equation is what? That is hc divided by 2 lambda. ಹೌದಾ? Suppose if I take the ratio of E1 divided by E2, it is hc by lambda into hc 2 lambda divided by hc. Howda? So here hc will get cancelled, lambda will get cancelled. Whatever your energy is there, it reduces to half. Yes, that is option C is correct. Option C is correct. Next question, what happens to the wavelength of a photon after does it collide with an electron? So what happens to the wavelength of a photon after does it collide with an electron? Increases. Damini is saying increases. Nodana enagatte anta illi nodi. So here what happens to the wavelength of a photon? So again E is equal to hc divided by lambda is our formula. So ಇಲ್ಲಿ ಏನಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು, ಏನಾಗತ್ತೆ ಎದಕ್ಕೆ, that is for the wavelength when two electrons will collide. So ಯಾವಾಗ two electrons collide ಆಗತ್ತೆ, ಅದರದ್ದು ಎನರ್ಜಿ ಏನಾಗತ್ತೆ ಹೇಳಿ, the energy becomes decreasing. So energy is decreasing in the sense, what happens to the wavelength? The wavelength value increases. Yes, option A is correct here. Option A is correct. Option A, Parvati. It is option A. Abhishek is saying A. Yes, correct. I hope the solution is clear to you. We will go for the next question. Why are alkali metals most suited as photosensitive metals? Why are alkali metals most suited as photosensitive metals? Because of the high frequency, because of the zero rest mass, because of high work function, because of low work function. Yes. Any idea? Gottidya enadru? Kumar is saying option D. Rakshita is saying option D. Samarth is saying A. Kumar D. Monica D. Yes, D is the correct option here. D correct agide because of the low work function. Because of the low work function. Yes. The next question is, which radiations will be most effective for the emission of electrons from a metallic surface? Microwaves, X-rays, ultraviolet, infrared. So ಯಾವುದು ಜಾಸ್ತಿ suitable ಇದೆ for the emission of the electron from the metal surface? Akash is saying ultraviolet. Rakshita, Kumar, yes. Damini, yes, students, very good. That is option C is correct here. Ultraviolet correct agide. That is the radiations which will be most effective for the emission of the electron. That is ultraviolet. Aita? Then the next question. Photoelectric emission is possible at all frequencies, whether it is true or no. Yes? Correct agidya, tappagidya? It is true. False. Yes, photoelectric emission is correct. It is false. Ella frequency ku baralla. ಹೌದಾ ಎಲ್ಲ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಸೂಟ್ ಆಗಲ್ಲ ಇಲ್ಲಿ ನಮ್ಗೆ ಏನ್ ಬೇಕಾಗತ್ತೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬೇಕಾಗತ್ತೆ so that minimum frequency is only called as what threshold frequency anta karitare it is called as threshold frequency so it is false. Next question. Two metals A and B have work functions 4 electron volt and 10 electron volt respectively. Which metal has a higher threshold wavelength? So which has a higher threshold wavelength? How you are going to do it? That is, it is nothing but E is equal to, it is H C by lambda. So ಅವ್ರು ಏನ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ ಅವರು ವರ್ಕ್ ಫಂಕ್ಷನ್. So work function, or you can say it as an energy only. Which metal has a higher threshold wavelength? So which is having lower energy, that will be having higher wavelength. How the metal B or metal A? Yes, option A is correct. Option A is correct here. Okay. Then the next question. Give the unit of work function. Electron volt, joule, hertz, watt. So what is the unit of work function? Actually electron volt ಬರುತ್ತೆ joule ಕೂಡ ಬರುತ್ತೆ ಅವರು ಇಲ್ಲಿ ಸ್ಪೆಸಿಫೈ ಮಾಡಿಲ್ಲ they have not specified whether it is a SI unit ಏನಂತ ಸ್ಪೆಸಿಫೈ ಮಾಡಿಲ್ಲ so we can consider it as a joule, no problem, we can take it as a joule is the unit. Okay, then the next question. What is the frequency of a photon whose energy is 66.3 electron volt? So what is the frequency? So the frequency we require here now in ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ, that is given by formula E is equal to h nu is our formula. Nu ಅಂತಂದ್ರೇನೆ frequency ಅಂತ ಆಗುತ್ತೆ. So substitute the value. Energy ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ? Energy 66.3 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. It is 66.3. Then next, it is in terms of electron volt. So electron volt ಅನ್ನ ನಾವು ಕನ್ವರ್ಟ್ ಮಾಡೋಣ joules ಅಲ್ಲಿ. It is 1.6 into 10 raised to minus 19 conversion factor ಆಯ್ತಾ. So divided by what? That is h value, Planck's constant. I'll take it as 6.6 into 10 raised to minus 34. So what is the frequency value? So ಎಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್? ಎಷ್ಟು ಬರುತ್ತೆ? ಆಪ್ಷನ್ ಡಿ ಕರೆಕ್ಟ್ ಆಗಿ ಬರುತ್ತಾ or it is coming 10 to the power of 15? See, if you take 1.6 then it is 10 raised to 16 ಕರೆಕ್ಟ್ ಆಗಿದೆ, ಅಥವಾ 16 into 10 to the power 15 ಅಂತ ಕೂಡ ನಾವಿಲ್ಲಿ ಮಾಡಬಹುದು ಆಯ್ತಾ. ಕರೆಕ್ಟಾ? ಹೌದಾ? ಎಸ್. ಸೊ ಐದರ್ ಇಲ್ಲಿ ಸ್ವಲ್ಪ 10 raised to 16 ಇದೆ, ಇಲ್ಲಿ ಏನಾದ್ರೂ ಡಿ ಆಪ್ಷನ್ 10 to the power 15 ಇದ್ರೆ ನಾವು ಡಿ ಆಪ್ಷನ್ 10 to the power 15 ಅಂತ ಚೂಸ್ ಮಾಡಬಹುದು. Yes, next question. Calculate the energy of a photon of wavelength 6600 angstrom. Calculate the energy of a photon of wavelength 6600 angstrom. So similar formula, that is nothing but E is equal to hc divided by lambda. Calculate the energy. So h 6.6 into 10 raised to minus 34. C value 3 into 10 to the power of 8. Then lambda value 6600 into 10 to the power of minus 10. Okay. ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ? Shilpa is right. Again, other students. Kumar. Correct. Okay. So option D is right. Option D or option C it is. If you simplify this, you are not getting this one. That is 6.6 into 3 divided by 6,600 into 10 raised to minus 19. It is not coming 0.003 into 10 to the power of minus 16. Istu barattala idu. Yes. So 10 to the power 16 ಅಲ್ಲಿ ನಮಗೆ ಆಪ್ಷನ್ ಇಲ್ಲ ಇಲ್ಲಿ. ನೀವು ಡೆಸಿಮಲ್ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಯಾವ್ದು ಬರುತ್ತೆ ಇದರಲ್ಲಿ? A B C D. Yes, option B is correct. Option B is correct. Option B is correct. ಇಲ್ಲಿ ನೋಡಿ ಡೆಸಿಮಲ್ 1 2 3 3 ನೀವೇನಾದ್ರೂ ಇಲ್ಲಿ ಈ ಕಡೆ ತಗೊಂಡ್ರಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ 10 to the power 19 ಬರುತ್ತೆ. So option B is correct here. Okay. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. Okay, which of the following increases the maximum kinetic energy of the photoelectrons emitted? Which of the following increases the maximum kinetic energy of the photoelectrons emitted? Yes, option A, increasing the frequency of the incident beam, increasing the velocity of the electrons, decreasing the frequency of the incident beam, increasing the mass of the photoelectron. Yes, option A is correct. That is increasing the frequency of the incident beam. Increasing the frequency of the incident beam, the kinetic energy of the photons will be emitted. Okay. So option A is correct here. Let us go for the next question. The next question is, who is responsible for the photoelectric effect experiment? Albert Einstein, Max Planck, Heinrich Hertz, de Broglie. Who is responsible for the photoelectric effect? C, yes, correct. Okay, that is, so in 1887, the first time the photoelectric effect was explained by, it is Heinrich Hertz. Correct agide. So that is option C is the right one. Then the next question, identify the conclusion of the photoelectric experiment from the following. Photons are smaller than the electrons. The energy in light comes as a small packets. The energy in light comes as a huge packet of energy. The energy released by the photoelectric effect is very less. So which is from the photoelectric experiment conclusion? Option B. Yes, very good. So that is the energy is in the form of a small packets. Option B is 100% correct. Okay. Then the next question. The photoelectric effect is commonly found in solar panels. It is true or false? The photoelectric effect is commonly found in the solar panels. Yes. Yes, it is true. False ಯಾರು ಹೇಳ್ತಿದ್ದೀರಾ? True ಇದು. ಹೌದಾ? So solar panels ಅಲ್ಲಿ ನಾವು photoelectric effect ಅನ್ನ ನೋಡಬಹುದು. ಅಲ್ಲಿ ಸಿಲಿಕಾನ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಮೆಟಲ್. Then the next question, find the odd one out. Find the odd one out. Option A, chlorine. Option B, sodium. Option C, oxygen, and option D, helium. Find the odd one out. So carefully observe ಮಾಡಿ ಯಾವುದು odd ಆಗುತ್ತೆ ಇದರಲ್ಲಿ. Chlorine. ಯಾವ reason ಗೆ chlorine ಆಗುತ್ತೆ? Helium. Damini is saying it is helium. Can anyone tell why it is? Helium is the right answer. Helium correct ಆಗಿದೆ. ಆದ್ರೆ ಯಾಕಂತ ಹೇಳ್ಬೋದಾ? ನೀವೇ ಹೇಳ್ಬೋದಾ ಯಾಕಂತ? Yes, students, why it is helium? Why it is helium? Chlorine, sodium, oxygen. ಏನಾಗುತ್ತೆ? Yes, who is giving the answer? Because hydrogen, chlorine, and oxygen are non-metals, while the helium is a noble gas. Very good. So Damini, it is right. So here the helium is a noble gas. Others are the non-metals. Or metals, it is oxygen, sodium, chlorine. Non-metals or metals? It is metals, na? ನೋಡಿ ಕೆಮಿಸ್ಟ್ರಿ ಯಾರಿಗೆ ಒಳ್ಳೆ ರೀತಿ ಬರುತ್ತೆ ನೋಡಿ. I feel it is metals. ಹೌದಾ? So it is metals and the helium is a noble gas. Yes, the next question. Pick out the apparatus used in the experiment of the photoelectric effect from the following: electron gun, vacuum tube, metal tube, and the glass tube. Yes? Any idea? Option A? No. So the apparatus which is used in the photoelectric effect is the glass tube. Option D baratte. Option D is correct here. Okay. So we use the glass tubes. Electron gun antu ಮಾಡಲ್ಲ ಯಾಕಂತಂದ್ರೆ ನಮಗೆ electrons ಅದರಿಂದ ಸಿಗುತ್ತೆ ಹೌದಾ metal surface ಇಂದ. So it is a glass tube. Yes, our next question. What is the frequency of a photon whose energy, sorry, it is repeated alla, idu repeat agide. This is also repeated. Okay, then the next question. What will be the photon energy for a wavelength of 5000 angstrom if the energy of the photon corresponds to the wavelength of 7000 angstrom is 4.23 into 10 raised to minus 19 joules. Okay, so here that is what we need to do. ನಮಗೆ already equation ಗೊತ್ತಿದೆ, ನಾವು ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ರೇಷಿಯೋ ತಗೋಬೇಕಾಗುತ್ತೆ ಆಯ್ತಾ. So because they are giving you the other wavelength and the energy values, therefore we know that E is equal to H nu upon, sorry, Hc upon lambda. ಹೌದಾ? That is E is equal to H C upon lambda. E and lambda inversely proportional ಇರೋದ್ರಿಂದ ನಮ್ಗೆ E2 ವ್ಯಾಲ್ಯೂ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, E2 upon E1 is equal to lambda 1 upon lambda 2 ಅಂತ ಬರುತ್ತೆ ನಮ್ಗೆ. Yes, so ನಮ್ಗೆ E2 ಬೇಕಾಗಿದೆ, therefore E2 is equal to lambda 1 value. So the lambda 1 is 5000 into 10 raised to minus 10 divided by lambda 2 is 7000 into 10 raised to minus 10. Sorry, ನೀವು ಇಲ್ಲಿ 7000 ತಗೋಬೇಕಾಗುತ್ತೆ ಯಾಕಂದ್ರೆ ಈವನ್ ನಾನು ಇಲ್ಲಿ ಎಷ್ಟು ಅಂತ ತಗೊಂತಾ ಇದ್ದೀನಿ 4.2 ಅಂತ ತಗೊಂಡಾಗ ಇದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ ಸ್ಟೂಡೆಂಟ್. ಸಾರಿ, ಸೊ ಇಟ್ ಇಸ್ 7000 divided by 5000 ಯಾಕಂದ್ರೆ ನಮ್ದು ಈವನ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ 4.23 into 10 raised to minus 19. ಇಲ್ಲ ಅಂದ್ರೆ ನೀವು ಫುಲ್ ಇಕ್ವೇಶನ್ ಅನ್ನೇ ಕೂಡ ಚೇಂಜ್ ಮಾಡಬಹುದು. Option A, B, C, D. Yes, C correct. Very good. So option C is correct here. We just need to take the ratio of two equations. We just need to take the ratio of two equations. Okay. So option C is correct here. Let us go for the next question. Photons of energy 10.2 electron, 25 electron volt fall on the surface of the metal, emitting photoelectrons of maximum kinetic energy 5 electron volt. What is the stopping voltage required for these electrons? Option A 10 volt, option B 4 volt, option C 8 volt, and option D is 5 volt. Yes. So here, ಇಲ್ಲಿ ನೋಡಿ ಅವರು ಏನು ಕೊಡ್ತಿದ್ದಾರೆ, that is the photon of energy. Energy is given, it is 10.25 electron volt. Energy is 10.25 electron volt fall on the surface of the metal, emitting the photoelectrons of maximum kinetic energy 5 electron volt. So ಇಲ್ಲಿ ಏನು ಒಂದು ಹಿಂಟ್ ಇದೆ, ಟ್ರಿಕ್ ಇದೆ ಅಂತಂದ್ರೆ, ಇದು maximum kinetic energy ಯಾವಾಗ, yes 5 volt is right. So they are giving you maximum kinetic energy as 5 electron volt. The stopping potential will also be 5 electron volt. Therefore, the option D is the correct option. Artha agta idea solutions? Okay. So our next question: when a proton is accelerated through 1 volt, then its kinetic energy will be 1 volt. True or false? Yes. When a proton is accelerated to 1 electron volt, then its kinetic energy will be 1 electron volt. Yes, correct. Very good, very good. That is, it is true. It is true. Okay. Then the next question. What is the energy of a photon of wavelength lambda? This formula ide. Formula options alli hc into lambda is given. Hc divided by lambda is given, lambda divided by hc is given, and lambda h divided by c is given. Which is the correct option? Yaad sariyagide? Yes, everyone should answer this. Hauda? Very good. So it is option B, hc divided by lambda. Hc divided by lambda. So next question. The next question is, which among the following shows the particle nature of the light? That is the option A, photoelectric effect, option B, interference, option C, refraction, option D, polarization. Yes. Very good. So everybody is saying that is photoelectric effect. It is the correct answer. Photoelectric effect, which shows the particle nature of the light. Our next question. What will be the number of photons emitted? What will be the number of photons emitted per second if the power of the radio transmitter is 15 kilowatt and it operates if the frequency is 700 kilohertz? Yes. How to do this one? So they are giving you the power value. Okay. So power ಎಷ್ಟಂತ ಕೊಡ್ತಿದ್ದಾರೆ ಅವರಲ್ಲಿ, that is given as 15 kilowatt, that is 15 into 10 to the power of 3 watt. ಹೌದಾ? Then the frequency is given 700 kilohertz anta, so it is again 10 raised to 3 hertz. The number of photons emitted per second is equal to, it is power divided by h nu. So power ಎಷ್ಟಿದೆ 15 into 10 to the power 3. Then h nu value. So h nu value is how much? It is 6.6 into 10 raised to minus 34 into nu value frequency 700 into 10 raised to 3. Yes. So the number of photons emitted per second. ಮಾಡಿದ್ರಾ ಯಾರಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರಾ? A, B, C, D 3.24 into 10 raised to 31, 3.87 into 10 raised to 25, 2.77 into 10 raised to 37, 3.2724 into 10 raised to 45. Yes. Option A. Correct. Everybody is getting? Yes. Very good. It is 3.24 into 10 to the power of 31. Okay. So students, I hope you are understanding. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಲ್ಲ? Next question ನೋಡ್ಲಿ ಅಲ್ಲ? So the lesson is little simple. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ fast ಆಗಿ ಹೋಗ್ತಾ ಇದ್ದೇವೆ ಇವತ್ತೆ. Okay. ನೋಡಿ next question. Confirms the which theory is confirmed by the Davison-Germer experiment? De Broglie theory, Newton's theory, Einstein's theory, Planck's theory. So here, which theory will confirm? Yes, very good, very good. So 100% correct. That is the de Broglie theory will confirm the Davison-Germer experiment. Davison-Germer experiment was confirms the de Broglie hypothesis ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ ಅದಕ್ಕೆ ಹೌದಾ? The next question. Which of the following is used in the Davison-Germer experiment? Double slit, single slit, electron gun, electron microscope. So Davison-Germer experiment. ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತಾನೆ? Electron single slit, double slit ಅಂತೂ ಬರಲ್ಲ ಹೌದಾ? So ಯಾವ್ದು ಬರುತ್ತೆ? Davison-Germer experiment used. So ಏನಿದೆ ನಿಮ್ದು ಆನ್ಸರ್ ನೋಡೋಣ. It is electron gun. Yes. So option C is correct here. ಹೌದಾ? Option C correct ಆಗಿದೆ. Then the next question. Intensity is different for different angles of scattering in the Davison-Germer experiment. Yes, whether it is true or false. Intensity is different for different angle of scattering. Yes, it is true or false? It is true. 100% true it is. How that? So it is 100% true. So let us go for the next question. So the next question is, that is, identify the expression for Bragg's law from the following. 2d cos theta is equal to m lambda, 2d sin theta is equal to n lambda, 2d sin theta is equal to n lambda, then 2d cos theta is equal to n lambda. So the options repeat ಆಗಿದೆ ಇಲ್ಲಿ. ಯಾವ್ದಿದೆ ಹೇಳಿ? Bragg's law. Which is the Bragg's law expression? Yes, other students, law ಬೇರೆ ಬೇರೆ ಕಡೆ ಬೇರೆ ಬೇರೆ ಕಲ್ತಿದ್ದೀರಿ. Yes, others, out of 17 ಬರೀ 2-3 ಜನ ಅಷ್ಟೇ ರಿಪ್ಲೈ ಆಗ್ತಾ ಇದ್ದೀರಾ. ಕರೆಕ್ಟ್. ಸೊ ನೀವು ಬಿ ತಗೊಳ್ಳಿ, ಸಿ ತಗೊಳ್ಳಿ, ಸೇಮೇ ಕೊಟ್ಟಿದ್ದಾರೆ. That is 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda. Yes. So it is correct. So now we will go for some of the previous year questions. Let us see some questions now. So here we have one question, that is, in the photoelectric experiment, the wavelength of the metal, the wavelength of the light incident on a metal is changing from, the wavelength is changing from hardly 1 to 2 marks will come from this lesson. So very simple lesson it is. Simple and short. So here the question is, in a photoelectric experiment, the wavelength of the light incident on a metal is changing from, wavelength is changing from 300 nanometer to 400 nanometer. Okay. The decrease in the stopping potential is close to. The decrease in the stopping potential is close to. Avaru nimge HC by E value kottidare, that is 1240. Yes, the options are given as A is equal to 2 volt, B is equal to 0.5 volt, and C is equal to 1 volt, and D is equal to 1.5 volt. The wavelength is changing from 300 to 400 nanometer. The decrease in the stopping potential. Yes, this is previous year question. What Rakshita is saying? It is not okay. I'll ask once again, sir. I sent him. I'll ask him. Okay. So see, the wavelength is changing from 300 to 400 nanometer. What is the decrease in the stopping potential? So all are getting option C. It should come B. 0.5 baratte nodi. 1 baratta 0.5 baratta nodi, correct ag nodi. Yes, 1 volt. Yes. So whoever don't know, for them, let us solve this one. The wavelength of the light is changing from 300 nanometer to 400 nanometer. The decrease in the stopping potential is, yes. So it is given as that is HC divided by lambda 1 is equal to pi plus EV1. This is my equation 1. My equation 2 will be same, but lambda 2 matte EV2 baratte. So 1 minus 2 ಮಾಡಿ. Equation 1 minus 2 ಮಾಡಿದಾಗ ನಾನು ನಿಮಗೆ ಇಲ್ಲಿ ಕೇವಲ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. V1 minus V2 into bracket, sorry, is equal to HC divided by E into bracket lambda 2 minus lambda 1 divided by lambda 1 minus lambda 2. So ಈ ತರ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಮಗೆ 1 volt ಅಂತ ಬರುತ್ತೆ ಇಲ್ಲಿ. So 1 volt is the right answer. Yes, very good. So one more question we will see. The ratio of wavelength. So the ratio of wavelength of proton and deuteron accelerated by potential. The ratio of proton and the deuterons accelerated with a potential Vp and VD is 1:√2. Then the ratio of VP and VD. I'll repeat the question. The ratio of wavelength of proton and deuterium is given as VP and VD in the ratio of 1:√2. Then the ratio of VP and VD is options A is 1:1, B is √2:1, C is 2:1, and D is 4:1. Question ಅರ್ಥ ಆಯ್ತಾ? ರಿಪೀಟ್ ಮಾಡ್ಬೇಕಾ? Yes, I'll repeat the question. The ratio of wavelength ratio and for the deuterium ಮತ್ತೆ proton ಮತ್ತೆ deuterium ಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. The ratio of VP and VD. The ratio of VP and VD. Yes, very good. So it is option B, √2:1. Option B, √2:1. Okay, students. So as you are telling that nimge questions bandila anta heltidira, I'll just check out that. So previous year questions I will forward you. Okay. So we will complete this class, dual nature of matter, radiation and matter. Next class we will continue. Thank you.
Thank you so much, ma'am.
Okay, thank you.